Hello everyone, welcome to the episode 30 in hexadecimal of Debugging TV Frames program. You can type your questions during this episode. If I can't answer particular questions now, I then post answers on the website debugging.tv. This episode is about data recovery via crash dump analysis using WinDBG, a Microsoft debugger from Debugging Tools for Windows. Of course, sometimes it is possible to use different, simpler tools, for example, streams from sysinternals or other debuggers or even hex editors. I just want to show how to use a debugger, WinDBG particle debugger. So this is what I saw before blue screen. I was typing a text on Notepad. I actually was typing the same text in Microsoft Word and was preparing a presentation in Microsoft PowerPoint. But blue screen happened. I confessed I did it myself. And also the system was configured to save a complete memory dump because all these buffers that we are going to recover are in user space, and so kernel memory dumps are not useful here. And so let's start analyzing that complete memory dump. I now switch to WinDBG session. I have already opened memory dump and even applied symbols from Microsoft Symbol Server. So what we start? First of all, we check any mapped files using address command. Remember, just before blue screen I was working with presentation. So let's search for if there's any map file like ppt x or ppt. And indeed, we find one. Actually, we have the start address of it and size. So what we do now, we take, so we use command write mem. Specify a file name to save memory. Say, let it be debugging. Say 1 pptx, and then we supply the start and length. Actually here I need to subtract 1 byte. I think let's try without that. No, we don't need to subtract, only if we supply and address. We need to decrease by 1 byte. Okay, so all these bytes were saved. So let's now look to this folder. We see this file and you see, let's open it. So we were able to repair this file. Some images are not good, but still we are able to see So you see, I just started writing this presentation, changing the previous. There are some slides from the previous presentation. So I was able to recover. Just started changing, writing new presentation, and then blue screen happened, and I'm able to recover new slides. So let's close. So let's go back to WinDBG. So next task is just, let's see if we have Notepad. Remember, I was typing something in Notepad, and also next we also look at Microsoft Word. So let's dump the list of processes. So you see there is indeed Notepad. So let's switch to this Notepad. I think I made a mistake. Dot needs to be instead of comma. So we switch to that process, and if you repeat address command, it will also show what's inside user space for the current process, now Notepad. I scroll up, and then what we see, all memory regions in kernel, but on top, indeed, so on top we see user space. So all this. So the first thing, of course, is to remember what we were typing. But let's not find that, but find just Unicode or ASCII strings, say with the length higher than 20. So of course, because this is an editor, so most likely all these buffers with what we were typing were saved in heap, in process heap. So we need to know where this heap is located. So most likely somewhere here, because we see lots of pages here. So, and this is also 64-bit address space. So actually, in order to search, we need to search a lot. So what we do, just to limit our search, because it takes time, we launch a Notepad, so we already have it, and attach another instance of debugger to it, just to see where roughly heap is located. So I need to fix symbols. What I did, I just attached a WinDBG to running Notepad. And then we type heap statistics, try to dump heap statistics just to see where heap is located. Of course, with each Notepad instance, heap segment location may be different due to address space layout randomization, called ASLR. But we get the idea where, the end of heap. So it starts somewhere here and probably ends around this address. So then we switch to our complete memory dump and search in roughly the same area. So we use search command, and then we specify L20, so just to filter out less strings, and then we search for Unicode strings. Most likely what we type is in Unicode, and then we specify address. I think it's something we take the hint from a real notepad and take something like this address. Just to limit our search instead of large 64-bit address space. Okay, it takes some time to dump Unicode strings, but it should be faster than dumping all address space. Should finish quickly. Okay, let's search what we are typing. We were typing something like hello space, so let's search. And indeed we find one such buffer here in Notepad. Actually there are several locations. So you see. So the same can be done for Microsoft Word. So if you type process, if you dump process list, we find Microsoft Word here as well. So switch to it, and then we repeat address. Now instead of scrolling, we just search for address. So I think we type still Notepad, so let's double check. So this is our Microsoft Word process and structure address. Yeah, I think we repeated the same switch to Notepad. So let's repeat address. For Microsoft Word, address space is a bit more dense because it's a huge application compared to Notepad. So it's not very easy to find heap to search. There are lots of regions. But again, we can attach WinDBG to existing copy of Microsoft Word. Do reload, and then get heap statistics. So basically you see that heap, so depends on what you see on the heap, then you can search. At least you get idea where to limit our search. And I already did that for Microsoft Word. It takes longer to dump. So this all the output was saved in a log file, and again we see a buffer. So the location here is a bit different than we have here. So what we do, actually, just to test, we launch another copy of Microsoft Word. And let's attach again. So the different heaps. I don't know how, but the heap was much bigger, and addresses were actually a bit bigger when I did before in this presentation. But you see that heap, due to address space layout randomization, heap are different. Heap locations are different. But anyway, I was able to recover the buffer from Microsoft Word as well. So I limit the search, I think, something to this address. So okay, so this is our demonstration. So now this is the usual add slide of upcoming training sessions and free webinars. Please note that there's also forthcoming accelerated Windows malware analysis training in August. And we also plan an accelerated network trace analysis training, but haven't yet decided dates for final announcements. And so, thank you for watching this episode. Please later check out the slides and recorded video from debugging.tv. The next episodes should be on the 5th and 12th of August due to training sessions in the meantime. So there are no more episodes in July. So okay, thank you for attending and see you in August. Bye-bye.